Hello students, in this video I'm going to go over assignment U3A00, which is a bunch of Regents questions that I put together for the past couple of years related to this particular topic, which is finding area and perimeter of triangles and categorizing triangles. Let's take a look. So for the first question, number 33 out of August 2015, the question reads, Triangle ABC has vertices of A is x comma 3, B is negative 3 comma negative 1, and C is negative 1 comma negative 4. Determine and state a value of x that would make triangle ABC a right triangle. Justify why triangle ABC is a right triangle. Alright, so to do this, it says that the graph is optional. I would definitely encourage you to use a graph just because this is so visual. It doesn't hurt just to graph this out. So negative 3 comma negative 1 is located over here, and I'm going to call this B. C is negative 1, negative 4, which is right here. And A is x comma 3. So that means I have a horizontal line. This is y equal to 3. We need to find an appropriate x coordinate that will form a right triangle out of this. Now, looking at this, I noticed that slope BC here has a slope of negative 3/2. So therefore, the slope of AB, in order for this to be a right triangle, it must be the negative reciprocal of this guy. Okay, so the slope of AB must have a slope of 2/3. Okay. So looking at this, if I go 3 over and 2 up and 3 over and 2 up, I want to land right there, and this is going to be my A. So A will have a coordinate of 3 comma 3. So to justify why is triangle ABC, because it says to justify here, why is triangle ABC a right triangle? So we can say then, since the slope of AB is the negative reciprocal of BC at point B, there will be a right angle. Triangle ABC is a right triangle. And that's the justification. Okay. The coordinates of the vertices triangle RST are negative 2 comma negative 3, 8 comma 2, and 4 comma 5. I'm going to use the graph from above here just because, again, this thing is so visual. I'm going to use red. So negative 2 comma negative 3 is located right here. And this is my R. My S is located at 8 comma 2. So 8 comma 2 is going to be 3, 6, 8, 2. It's right there. This is my S. And my T is 4 comma 5. 4 comma 5, 4, 3, 5. This is my T. And it looks like this. Okay. And it looks like that. Okay, so RST, it looks like, just based on this, right? RS has a slope of negative 3/4, whereas RT, it looks like it has a slope of positive 4/3, and angle T then looks like it's going to be a right angle. So therefore, it has to be a right triangle, not obtuse, not acute, and not equiangular. Okay. All right. The diagram below, triangle ABC, has vertices 4, 5, 2, 1, and 7, 3. What is the slope of the altitude drawn from A to BC? So something you need to know, we didn't cover this yet, at least not up until this point in the lesson series, because this is the first lesson out of Unit 3. But an altitude, okay, is a line drawn from a vertex such that the line from the vertex drawn to the opposite base has to form a 90-degree angle. So it says here, what is the slope of the altitude drawn from A to BC? So from A, that's the vertex, right? It has to be drawn like that. So if you look at BC, the slope of BC, what's the slope of BC? The slope of BC is 2 fifths. The slope of the altitude, therefore, must be the negative reciprocal of it because it has to form a 90-degree angle. So it's got to be negative 5 halves, which is this guy right there. Okay, moving on. Triangle RST is graphed on the set of axes below. How many square units are in the area of triangle RST? Okay, so this is just like right out of the lesson. And the technique that I had shown you guys was to graph this thing inside of a rectangle. I also notice that this is a right triangle as well. How do I know that? Well, that's because SR here, I go up 2, 4, 6. Well, actually, it has a slope of 2, right? Whereas ST has a slope of negative half. Okay. There are a couple of ways that we can go about this, actually. Well, I'll go about it the way that I had shown you guys in the lesson here. Actually, I went through in both ways. So you know what? I'll do it the short and easy way first. When I say short and easy, I'm going to use the area of the triangle, 1/2 base times height, right? So if you look at this, triangle RST is already a right triangle. If I find the length of RS, and multiply that by the length of ST, that is going to be the area, and divide by 2, that is going to be the area of the triangle. So RS, looking at that, that's Pythagorean theorem there. I go up 6 and over 3. That's just the square root of 6 squared plus 3 squared. That's the length of RS. And then the length of ST, it looks like I go down 1, 2, 3, 4, 5, 6. I go down 6, and I go over 12. Okay. What is that? That's going to be 36 plus 9 is 45, right? And 6 squared plus 12 squared, 144 plus 36, that's 180. And if you look at this, right, square root of 45, or actually square root of 80, is actually 4 times 45. Which means all of this becomes, well, since I have 2 square root of 45s here, they become just 45, and the square root of 4 is just 2. So this becomes 1/2 of 2 times 45. So this is just 45. If you dislike the way that I solve this, of course you can always go back and just find the area of each of these triangles here and then subtract from the overall. So this guy right here, 3 times 6 divided by 2, is 9. This guy right here, 6 times 12 is 72. Divide by 2 is 36. This guy right here, what is that? 2, 4, 6, 8. Wait, let me see. 2, 4, 6, 8, 9. 2, 2, 4. Sorry. 2, 4, 6, 8, 10, 12. So 9 and 12. So 1/2, 9 times 12, that would be 54 then. So I'm going to take 36 plus 9 plus 54. What would that be? That would be 45 plus 54, which is going to be 99. And if I multiply and then find the total area of this thing, right? 3 plus 9, that would be 12. So this is a square. It's 12 by 12. It's 144. 144 minus 99 is in fact 45. Okay? So we end up in the same place. So solving it both ways. The coordinates of vertices A and B of triangle ABC are shown. Okay, if the area of triangle ABC is 24 square units, what could be the coordinate of point C? So, let's draw this thing out. So, A is 3, 4, so I'm going to put a point right there. And B is 3, 12, so that's directly above. So this has a height of, or actually AB has a length of 8 then. And I want, and triangle ABC, let's say right there, okay, has an area of 24. So it could be in the first quadrant, or it could even be in the second quadrant. So in order for this to be, in order for this to have an area of 24, it could either be like this, or it could be like this, ABC, right? And I believe it is going to be down here. It's going to be this guy, right? Since this guy is 3, this guy should also be 3, because 3 times 8 gets you 24. Since I'm 3 away from A, it would have to be 6. So that's why it's option 4 there. Okay, June 2017. On the set of axes below, the vertices PQR have coordinates of that. What is the area of triangle PQR? Okay, so PQR, looking at this, and it looks like this is a right triangle right there. So again, looking at this, this is 3 over 3 and up 4, so that means this has an area of 6. This is up 6 and over 8, so that means this has an area of 24. Up 6 and over 8, right? Let's see here. 2, 4, 6, 8, 2, 4, 6. Yeah. And then this guy over here is down 12, right? And over 2, 4, 5. So that means this has an area of 30. So if you combine all this together, this will be 60. So the area of the entire thing, what will be the area of the entire thing? Let me see here. 2, 4, 6. 2, 4, 6, 10. 2, 4. Oh, I'm sorry, I got this wrong. It's not 30 here. So let's see here. This is 2, 4, 2, 4, 6, 8, 10. 10, 2, 4, 5. 10 and 5. So this is actually 25. My mistake. Okay, so this overall length here is 8, and the overall height is 10. So I'm looking at an area of 80. 80 minus 60 is 20. So that's this guy. Of course, you didn't have to go down that route. You can also do base times height, but since I did it already, I think you get the idea. Okay. So it says triangle ABC has vertices given by that, and triangle DEF has vertices given by those. Graph and label ABC, DEF on the axes below. Determine and state the single transformation where DEF is the image of ABC. All right, let's do that. A is negative 5, comma 2. Negative 5, so 2, 4, comma 2, so that's A. Negative 4, comma 7. Negative 4, comma 7. 2, 4, 6, 7. So that's B. And C is negative 2, comma 7. Negative 2, comma 7 is over here. So that's ABC. Let's now graph DEF. D is 3, comma 2, and 2, and so D is 3, comma 2. E is 2, comma 7. 2, comma 7. And F is 0, comma 7. So that's DEF. So it says describe a determine and state the single transformation where DEF is the image of ABC. So I would say that this would be a reflection over x is equal to negative 1 of DEF. Okay. Triangle DAN is graphed on a set of axes below. The vertices, DAN, have coordinates negative 6, comma negative 1. Blah, 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 blah. Okay. What is the area of DAN? Okay. So, I'm going to try to solve this a little differently because I notice something over here. Let me see here if I can do it this way. Let me see here. 2, 4, 6, 8, 10, 12. 2, 4. So it's 12 and 4. And then this guy is 2, 4, 6, 8, 9, and 3. Nope, I can't do it. So I was going to use altitude and base, but it's not a perfect altitude, so I'm not going to do it that way. So 2, 4, 6, 8, 9. So this is 9. 2, 4, 6, 8, 9. 2, 4, 6, 7. I'm going to go over here. This is 3. 2, 4, 6, 8, 10, 11. Oh, I couldn't. I should have just added 7 and 4 to get 11. I did not need to count there. So anyway, this has an area of 33 over 2. This has an area of 63 over 2. And this has an area of 4 times 12, 48, so 24. And I add them all together, I end up with what? So 63 and 33 adds up to 96 over 2. 96 over 2 is 48. So at 48 plus 24 is 72. 72 is the area of all those triangles on the outside. I will need to subtract this from 11 times 12, which is 132. And if I perform that subtraction, that would give me 60. So the answer is 60. Okay. Number 32, triangle ABC has vertices with coordinates -1, -1. Okay, so there's a lot of graphing here. -1, -1. 4, 0, 2, 4. And 0, 4, which is right there. So that's A, B, and C. Prove that triangle ABC is an isosceles triangle, but not an equilateral triangle. So an isosceles triangle tells you that there are two sides that are congruent. Okay, so AB has a length of 2. So if I go from A to B, I go 2, 4, 5, and up 1. So that's going to be a square root of 26. BC, I go 2, 4, and then 2, 4. So that means it's going to be 16 16ths the square root of 32. And then AC has a length of square root of 26. So since AC is equal to AB, triangle ABC is isosceles only. Okay. Last page. On the set of axes below, triangle ABC has altitude CG and a median CM are drawn. Which expression represents the area of triangle ABC? So, apologies here, but okay, so a median is this guy right there, and that's not the altitude. And you can kind of tell that the median does not form a right angle. Since it does not form a right angle, you cannot use that to find the area. Which expression can be used to find the area of triangle ABC? Well, we can use the altitude, which is GC, right? So GC times the length of AB, divide by 2, and that will give you the area, because it's base times height. The height is the altitude. So which option is that? GC times AB over 2. That would be option 4. So again, MC here is the median, and that is cannot be used to find the area of the triangle, unless the median turns out to be the altitude as well. But in this case, it's not. Triangle has ABC. Prove that triangle ABC is an isosceles right triangle. Here, so I want to find that the lengths of all these things. So AB is equal to 2 minus 4 is 2 squared, plus 6 minus -2, so that's 8 squared. This would be 68, square root of 68. BC has a length of -1 minus 2 is 3, so it's 3 squared. 1 minus 6 is 5, so it's plus 5 squared. And that would be 25 plus 9 is 34. And AC, what would AC be? -1 minus 5. -1 minus 4 is 5 squared. 1 minus -2 is 3 squared. So that would be square root of 34 as well. So this proves that ABC is isosceles. ABC is isosceles. And now what I have to do is find out the slope of BC and the slope of AC. So slope of BC, -1 minus 2 is -3. 1 minus 6 is -5. So that would be 3/5. So if it all goes well, I should end up with -5/3 as the slope of AC. Let's see if that's the case. -1 minus 4 is -5. And 1 minus -2 is 3. And indeed, it is negative reciprocal. So this is the negative reciprocal. So ABC is isosceles and right. And the last question. Determine and state the area of triangle PQR whose vertices are given by this. So -2, -5, -2, -5, that's P. 3, 5 is Q, so 3, 5, 2, 4, 5. And R has a coordinate of 6, 1. 2, 4, 6, 1. These are like the same problems repeated over and over and over and over and over again. I hope you guys are beginning to see that. Okay, so looking at this, I go over 3 and down to 4 and down 4. Here I go over 2, 4, 6, 8. And here I go 2, 4, 6. So I immediately notice that this is going to be a right angle. I want to solve this a little differently. So I know that QR has a length of 4 squared plus 3 squared, which is equal to 5 squared, or just 5, right? And PR has a length of, because it's a 3, 4, 5 triangle, will have a length of 10. So therefore, I can say area is equal to 1/2 base times height. So area is equal to 1/2 of 10 times 5, which is equal to 25. And that's it.